Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see sixth chapter of the book Loop Quantum Gravity for Everyone, authored by Rodolfo, Gambini and Jorge, Pullin, that is Loop Quantum Cosmology, in which by applying physics and mathematics of loop quantum gravity on cosmos, we can have separate branch that is loop quantum cosmology. We know that when we are talking about universe, we are talking about large scale of the order of galaxy, where our universe is homogeneous as well as isotropic. It means property of universe is same in all points and in all direction. So in LQG, there are certain assumptions on initial conditions so that we can remove Big Bang or singularity by Big Bounce model that we will see. If I extrapolate our universe in the backward direction, we will reach at the point where singularity were there, a point where Big Bang was occurred. And in LQG, there are certain mechanisms, as I told, and certain assumptions on initial conditions so that we can eliminate this singularity. We know earlier I explained that Thomas Thiemann gave quantization or quantized version of Einstein's field equation using which we can have certain things to say on Big Bounce model that eliminates Big Bang. It is regarding some approximation techniques that removes singularity or Big Bang through Big Bounce model. So in LQZ, physicists of loop quantum community use a Stucker-Lewandowski measure, which is the robust feature of loop quantum gravity, through which Ojewald, Stucker, Pawlowski, Singh, and many others gave loop quantum cosmology with approximation to full theory. Here, another striking feature of loop quantum cosmology is there is a minimum limit, certain limit on volume, so that we can eliminate singularity from space-time or quantized space-time, quantum space. We know that in Big Bang, because volume tends to become zero, we can have density becomes infinite. And that is why there were singularity. But what happens in loop quantum gravity, as loop LQG is considering Planck units, there is a fundamental limit on volume, that is 10 raised to minus 105 meter cube, so that we can eliminate volume's value that was zero in Big Bang model, and by this mechanism and method using the mathematics of loop quantum gravity, we can eliminate singularity of Big Bang. So here in this diagram I have shown what is Big Bounce model. Big Bounce model tells cycle of universe. Here at this point singularity is there. Initially, what happens after inflation, our universe expanded up to certain point, and thereafter it will again contract in this direction, and it will again re-expand in the past, again recontract in this direction. So this is like one cycle of universe. At this point, singularity is eliminated by mathematics of loop quantum cosmology, and as we are talking about Planck units, here volume is of the order of 10 raised to minus 105 meter cube. Thing is, another question is, can we observe like Big Bounce like phenomena? But I can say that as we cannot reach up to Planck energy, we cannot observe Big Bounce like phenomena. We know that world's biggest laboratory or experimental lab, which is situated near Switzerland France border, that is Large Hadron Collider, could reach up to 10 raised to 12 electron volt. But when we are talking about big bounce model, it means we are talking about 10 raised to 28 electron volt. It means Planck energy. That is why we cannot observe big bounce model using current experimental features. So at present, we cannot observe big bounce model. But how can we predict that it was occurred? There are certain mathematics, certain assumptions, and certain inferential techniques through which we can say that it may be possible that big bounce was occurred. For instance, in that phase, density of universe was so high that universe were opaque for light. We know that whatever communication that we are doing by means of light, if there is a no light, there is a no electromagnetic wave, we cannot communicate with each other. Whatever signals that we are receiving from distant object are receiving by means of light. In initial phase, our universe was opaque for light, so that we can only observe certain phenomena after our universe becomes transparent to light. So we cannot communicate without light, and after universe cooled off, atoms were formed and universe becomes transparent. We know that how we can receive electromagnetic waves by transition of electrons from one state to another state in orbits. But here we are talking about phase of universe where atoms were not there. And that is why if atoms were not there, how can we receive light? And this was the biggest hurdle to receive any kind of electromagnetic wave that could tell us about initial phases of our universe or evolution of universe. So whatever data that we have, we can say that initially our universe had long era where there was no geometry or there was no space-time. After certain development or after evolution, first of all, background was created or geometry was created. It means, first of all, gravitational force was created. Thereafter, we reached to GUT era. It means Grand Unified Theory, Grand Unified Era, where other three fundamental forces were there as one unified force. There were certain kind of symmetry between these three forces, that is electromagnetic force, strong nuclear force, and weak nuclear force. Thereafter, we reached to electronic era. Thereafter, creations of particles began. And thereafter, we reach to era of stellar nucleosynthesis. And from this era, various particles, various like quarks, protons, neutrons were created. And thereafter, nuclei, we reach to era of nuclei, where various nuclei were created. And at this era, which we call era of atoms, after which we can receive various electromagnetic waves from distant region of universe, we can observe our universe evolution. And thereafter, we reach to era of galaxies, and this is the present era of our universe, where there are 10 raised to 11 galaxies. And in each galaxy, there are approximately 10 raised to 11 stars. And each star has its own solar system. So what happened, whatever communication or whatever data we are receiving by means of microwave radiation, or it is known as cosmic microwave background radiation. How it was invented, let us see. After cooling off our universe, that light was made transition into another region, that is microwave background radiation, that we are receiving from observatories and satellites which are orbiting around Earth. In 1960s, scientists Penzias and Wilson, who were dealing with noise in microwave antenna, found that these noise were nothing but microwave radiation that they were receiving, and they called it microwave background radiation or cosmic microwave background radiation. For this discovery, they also received a Nobel Prize. As from these cosmic microwave background radiation, we could figure out picture of baby universe or celestial sphere. Here, actually, we cannot show, or I cannot show the actual picture of baby universe in black and white board. But if you Google it, you will see that this picture has many colors. Actually, telescopes receives data in terms of electromagnetic waves, not in terms of visible colors. So how they are decoding these things, let us see. In this picture of baby universe or celestial sphere, different color shows difference in temperature. So by means of coding in colors, we can say that there are certain kind of correlation by means of temperature in cosmic microwave background radiation. How can we say that there are correlation? By observing many times, and by many times many kind of data received by various kind of telescopes, scientists came to conclusion that there are correlation. But according to this data and whatever we have observed till today in cosmology, there are two problems in classic cosmology, that is horizon problem and flatness problem, which tells that initially when Big Bang was occurred, two regions were near to each other. But after Big Bang, these two regions are sharing same property. And according to Einstein's theory of relativity, no object can communicate with speed greater than speed of light. Then how could these two regions had same property? So this is the fundamental problem according to theory of relativity, which was solved by cosmic inflation theory given by Alan Guth and many other physicists. Another problem is flatness problem. Our universe seems flat for us, but actually it is not flat. But whatever data that we are receiving in terms of various cosmological parameters, according to which we can say that our universe is flat. But how can we solve these ambiguities? What Alan Guth proposed here is our universe was expanded with rapid acceleration, and by this mechanism, it may be possible that two regions had opportunity to share same property, and they may have opportunity to communicate with each other with speed equal to speed of light or less than speed of light. So in the beginning, according to fundamentals of cosmology, there were only quantum field. In terms of vacuum, we know that in quantum mechanics, empty space is wrong phenomena. So when we are talking about vacuum, we are talking about quantum fluctuation or 0 point energy. After cooling off, we have reached to the present phase of universe, that is era of galaxy and after era of present universe, and where temperature correlation is there, using which we can study the quantum cosmology and classic cosmology. According to observation in loop quantum cosmology, various physicists that belongs to loop quantum gravity community told that by means of various assumptions of loop quantum cosmology, loop quantum physics and mathematics of loop quantum gravity, they studied inflation in framework of loop quantum cosmology like physicists Aguilo, Astakar, Barrow, Mena, Almedo, etc. And they came to conclusion that loop quantum cosmology denies need of initial state vacuum in that phase. Why? We know that loop quantum cosmology or loop quantum gravity was originated from general theory of relativity, in which there were no presence of quantum field theory. To quantize theory of relativity or to quantize gravity, we require quantum field theory. So I am talking about that phase where there is no quantum things or no quantum fluctuation according to theoretical predictions of loop quantum cosmology given by these physicists. And they also predicted that there were enough dynamics that can explain why these vacuum states are not needed in inflation theory. There are subtle changes which made imprints as cosmic microwave background radiation in terms of large angular separation. I'm talking about this celestial sphere, using which and by studying these features, we can say that loop quantum cosmology has certain things to tell. By studying experimental limitation, there is not enough chance to observe this all kind of phenomena. But by tweaking these observations according to loop quantum cosmology and assumptions of loop quantum cosmology as per initial conditions, we can say that there is certain similarity between experimental observation and results of loop quantum cosmology, theoretical results of loop quantum cosmology. But here another limitation is we have not enough experimental data, so we cannot predict more regarding cosmological features of that point using loop quantum cosmology. So another thing is in inflation theory, in classic cosmology, inflatons are field of inflation, and by tweaking the data of inflaton using some initial conditions, loop quantum cosmology predicts exact outcomes as classical cosmology had. So these things are regarding loop quantum cosmology. In this lecture, we have studied how by using fundamentals of cosmology, we can reach to Big Bang model that is replaced by Big Bounce model in loop quantum gravity using fundamentals of loop quantum gravity like Astaker-Lewandowski measure. Thereafter, we show evolution of universe in terms of this data. Thereafter, we show what is cosmic microwave background radiation and how it is important in classic cosmology as well as in loop quantum cosmology, and how various physicists of loop quantum gravity community studies various cosmological phenomena in loop quantum cosmology. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture, you can ask in the comment section.